All right, let's look at problem number 7. It's kind of the same idea as number 8. We're going in circles. And if you remember from the last assignment, when you're going in circles, your y coordinate, or let's start with x, your x coordinate is always the x center of the circle plus r cosine omega t plus your starting point. Okay, this is the radius of the circle. And y is y0 plus r sine. Everything's the same, but it's sine, and of course it's y there, omega t plus theta 0. So this is your starting angle. Omega is how fast you're going in radians per second, right? The angular speed, the radians per second times second. That's the radius of the circle, and this is your starting point. Now they tell you they're going to use x is r cosine omega t minus pi over 2, and y is r sine omega t minus pi over 2, which means that the y center and the x center is 0. These are both 0. So they're making the center of the circle at the origin. Okay, now you didn't have to do that. You might want to make the center like this 0, 0, and the center of the circle is up a little ways. But they chose to make the center of the circle origin, so x0 and y0 is 0. They tell you theta 0 is minus pi over t, minus pi over 2, which makes sense because they're saying you're starting right there. Negative pi over 2, right? This is pi over 2 in the negative direction. You always start right here. You go negative pi over 2, so it makes sense theta 0 is negative pi over 2. So their formula is here, like y is omega t r. Now r is clearly 100, so this is 100. So we can rewrite these as x is equal to 100 cosine omega t minus pi over 2, and y is equal to 100 sine omega t minus pi over 2. The only thing we don't know is omega. Okay, r's are clearly 100, that's obvious. The thing we don't know is omega. How fast is this going? So they give us enough information to figure it out. They say at 5 seconds, again, mine is 5 seconds. Yours might be different, 4 seconds, I don't know. But they say it takes 5 seconds to go from the lowest point to right there. Okay, lowest point to right there. So right to this point Q, which is 44 feet above the ground, that takes 5 seconds. Okay, so the y value, we can figure out what the y value is there. First it's going to be negative because 0 is here, right? So it's going to be a negative y value. So we want to know what the y value is there. Now we know that's 44 feet above the ground. That's 44. And the center of the circle is 103 feet above the ground. That's really bad, 44. Because they say that point is, you don't want the Ferris wheel to hit the ground, it's 3 feet above. So this is 44. The whole distance to the center of the circle is 103. So y is the whole distance minus 44. So y is 103 minus 44, which is 59. It's 59 below 0, so actually it's negative 59, right? So really we should say, we want to know when the y value is negative 59. When the y value is negative 59, that's when 5 seconds have gone by, and we can then figure out how fast it's going. So we use our formula for y. So y is equal to r, which is 100, sine omega t minus pi over 2. And we want to know when that's equal to negative 59. So now it's just algebra. You put the 100 over there. So sine omega t minus pi over 2 is equal to negative 0.59. Take the inverse sine of both sides. So omega t minus pi over 2 is equal to inverse sine of negative 0.59. Oh, and t is 5. I forgot about that. T is 5 here. So we can replace t with 5. So I'm going to do that and put the t first. So we have 5t, because we know what 5 omega. We know that seconds, so after 5 seconds, so okay, we know that. So the only thing we don't know here is omega. Put the pi over 2 over here, take the inverse sine of negative 0.59, make sure you have your calculator in radian mode. If you don't have it in radian mode, you're going to get messed up. So make sure this is in radians, you take the inverse sine, add the pi over 2, keep lots and lots of decimal places. They want to 3 decimal places, and then you can figure out what omega is. You can figure out, yes, what omega is from that, and you plug it into here, and that's how many radians per second. Okay, then the second part is just kind of the same thing. They want to know when the rider's height above the ground is 80 feet, the first time and second time. So if we look at our picture, let me get it back there. We want to know when it's 80 feet. So the height above the ground is 80 feet. So there's 44 feet. So 80 feet is going to be something, I'll use a different color here. 80 feet is going to be somewhere up here and somewhere up here, right? This distance there is going to be, if that's 80, we know the center of the circle is 103, so this would be negative 23. So we want to know when y is equal to negative 23. And we'll get a point here, the first one, and we'll get a point here. So first it'll be here. Now we know it's going to be a little over 5 seconds. It took 5 seconds to get to 44. So 44 feet, so when it gets to 80 feet, it might be, I don't know, 8 or 9 seconds or something. I don't know. Or at least mine was 5 seconds. And then it's going to be a while to get back over here. Right? So you can kind of figure out roughly what the answer should be. But then you do it the same way. You just want to know when the y values of those things. We know everything we need to know. Omega we know now. We figured out what omega is. All we don't know is the time. So you do the same thing, but now you know omega, and you solve for the time. Okay, hope that works for you. Be really careful with calculator and radians. And solving all these things, keep lots of decimal places. Let's look at number 8 really quickly while I have your attention here. Again, same similar type of thing. We have to remember our basic formulas for trigonometry stuff. So number 8 says find parametric equations. That means there's a t in it. For the particle that moves along the circle, x squared plus y minus 1 squared equals 16. Now mine's different from yours, but let's draw that picture then. X center is 0, y center at 1. So part of this is drawing a really good picture. Make it way bigger than you think you need to. I always make mine too small. I'll try to make a big circle here. Oh, and I messed up already. The center is at 1. So, okay, try that again. So, and I know I don't need to, yeah, center at 1. So let's make this, and the radius is 4. So if this is 1, y equals 1 is the y center, radius of 4. So if that's 1, I go 4 higher than that. I'm going to go 3 lower than that. 1, 2, 3, 4, 1, 2, 3, 4. So radius of 4 goes all the way to here, 1, 2, 3, 4, yep, to here, and to down here. Now I connect all those dots. Okay, there's my circle, radius 4. So then they say, find parametric equations of the particle that goes on in the manner described. So once around clockwise, starting at 4, 1. So what we want, we're going to have, again, x is going to be x0 plus r cosine omega t plus theta 0. And y is going to be y0 plus r sine omega t plus theta 0. We need to know what all those are. We want to fill this out with nothing that we don't know. Now, first, x0 is 0, and y0 is 1. So we know those. At least for me, right? My y0 is 1, your y0 might be something else. And we know the radius is 4. So right away we know r is 4, and we know what x0 and y0 are just from looking at the circle. Okay, that's nice. Now we got to figure out the starting angle. They say it starts at 4, 1. X equals 4, y equal 1, which means this starts right there, which is the normal starting angle. That's the normal place you start. So my starting angle, theta 0, is equal to 0. So I know theta 0 is 0. Clockwise means it's going this way, right? Clocks go that way. So my omega, I know, is going to be negative. So be really careful that you know your omega is negative because it's going to go this way now. And it takes 2 pi seconds to make a circle. Okay, because it goes a full once around clockwise, one full circle between t equals 0 and 2 pi seconds. So omega is going to be, remember, omega is the number of radians divided by the number of seconds, the number of radians per second. It goes 2 pi radians, one circle, 2 pi radians, and from 0 to 2 pi seconds. It's 2 pi seconds. So 2 pi divided 2 pi is 1. So I know my omega is 1, except it's negative because it goes counterclockwise. So my omega is negative 1. Now I know everything about, at least for mine. I can do like my x. My x would be, the x0 is 0, radius is 4, cosine omega is 1, so I don't need to put it, so cosine t, and theta 0 is 0, so that's it. So I would write in here x equals 4 cosine t, comma, y equals, and then you guys can figure out your own y. Mine is, again, has a 1 plus, and then it's all the same thing. They want you to say comma separated list. Comma separated list, this is the way you'd write it. Make sure you put parentheses around the t, otherwise it'll think it's a word, C-O-S-T, which doesn't exist. So put parentheses around the t, comma, y equals the same thing. Okay? Now these other ones, okay, counterclockwise, you know omega is positive, starts at the same place, and it goes 3 times around, 3 circles, and 6 pi seconds. So it makes 1 circle and 2 pi seconds. So it's the same omega, same as here, halfway around in pi seconds. So it goes a full and 2 pi seconds. So again, always the same omega. Just be careful, it's negative here. Looks like mine is positive here. And then different points. Oh, but look, here it starts at 0,5. So you got to be careful at that one. Starts at 0,5, so you got to figure out what theta 0 is for that one. Okay? Here it starts the same place, so theta 0 is obvious. Okay. Hopefully that gets you started. If you know these basic formulas and think carefully about what omega is and everything, these really aren't that bad. Okay, good luck, and ask if you have any questions.